KenKen with Bob. I'm going to show you guys how to do one of the easier KenKens. This is a 4x4 square.
Because it's a 4x4 square, we're just using numbers 1 through 4.
What you do is put the numbers 1 through 4, one of them into each of these small boxes. And we cannot repeat in any row, and only once in each column.
I want you to notice these dark black lines because the dark black lines define a cage.
So for example here, this cage is a little bit odd shaped, has 3 squares, and everything, the 3 numbers that go into that cage, when multiplied together, you can see this multiplier here, must equal to 12. We'll get back to that in a second. This is an unusual cage in that it doesn't have any operator. There's no plus, minus, multiplier, divide. So we know that has to sum to 4. So now we can sometimes use what I call an elimination strategy. Let's just consider this column, the last column, and we know that there has to be a 3 somewhere in that column. In order to divide by 2, there's only 2 possibilities. 2 divided by 1 equals 2, and 4 divided by 2 equals 2. So only a 1, a 2, or a 4 can go in here. So similarly, only a 1, a 2, and a 4 can go in here. So there's no 3. This is the elimination strategy. No 3, no 3, no 3. The 3 has to go here. Let's go up here. This is what I call a factors strategy. What we need to do is find the factors of 16. So the only factors that can work here are 4 times 1, or 4 times 2 times 2. Let's try these 3. In fact, those are the only 3 that can work. And we know that the 2's have to go here because they have to be in different columns. So 2, 2, 4. So that's how we do the factors. This is obvious here, right? We need a 1, 2, 3, and a 4 in this row. We need a 1 here. Now we just want to fill in this cage. 3 plus 1 plus 3 is 7. Here we're going to fill in this row again. We need a 1. We're going to fill in this cage. We need a 3. Now how about factors of 12? Factors of 12.
Only a 3, a 4, and a 1 can work here.
We know we need a 4 here. We're filling in now the row. 1, 2, 3, 4. Here we need a 1 and a 3. The 3 can't go here. Now we know we have 1, 2, and 4 here. We only have 2 and 4 in this row. 4 can't go here, so we get a 2, a 4, and a 1, and a 2. And then you're done.